Hello, class. Today we'll be talking about 9.3, measuring weight and temperature. So remember in 9.2, we talked about going over the different things like measuring area and volume. And in 9.1, we talked about measuring length in the metric system. So today we'll be talking about 9.3. So some objectives for today. We're going to apply metric prefixes to units of weight. We will convert units of weight within the metric system. We are going to use the relationship between volume and weight within the metric system. We're going to use dimensional analysis to change the units of weight to and from the metric system. And we will understand temperature scales. So take a minute and make sure you understand that you can always pause these slides and we'll go through that. So weight and mass. So weight measures the gravitational pull on an object. Mass, the measure of the quantity of matter in an object determined by the molecular structure. Note, in this section, we're going to treat mass and weight as equivalent and refer strictly to weight. So take a minute and write this down. So let's look at some units of weight in the English system. We have 16 ounces is equal to 1 pound, and we have 2,000 pounds is equal to 1 ton. Now, the most common mistake people make is they think 1,000 pounds equal a ton, but it's actually 2,000 pounds that equal a ton. So keep that in mind and make sure you have that memorized. So these are the common English systems for weights, units of weights that we use for the English system. Let's look at the metric system. So the metric system, you've seen this before because in other sections we talk about kilometers, kilograms. Um, we talked about kiloliters in other sections. Now this is the same thing, but we're talking about grams. So we have kilograms, hectograms, decagrams. We have the base unit, which is grams. Then we have decigrams, centigrams, and milligrams. And we have their respective symbols beside them to the left, which is kg, hg, dag, g, dg, cg, and mg. Now, volume and weight in the metric system. 1 kilogram of water has a volume of 1 liter. So 1,000 cubic centimeters is equal to 1 cubic decimeter, which is equal to 1 liter, which is equal to 1 kilogram. So we have 1 cubic centimeter is equal to 1 milliliter, which is equal to 1 gram. So that's the volume to capacity to weight. We have 1 cubic decimeter is equal to 1,000 cubic centimeters, which is equal to 1 liter, which is equal to 1 kilogram. Now we have 1 cubic meter is equal to 1 kiloliter, which is equal to 1,000 kilograms, which is equal to 1 metric ton. And we'll talk about what a metric ton is next, after we do our first example. So let's look at this. It says the aquarium holds 0.25 cubic meters of water. How much how much does the water weigh? So now we start off with our 0.25 cubic meters. And we know we put that over 1. Then we multiply by our unit fraction. So if we want to go back to the previous slide, we know that if we're doing cubic meters, we know that what? We can change it to kilograms. So let's change the kilograms. So in 1 cubic meter, there's 1,000 kilograms. So 1,000 kilograms per 1 cubic meter. All right. As you know that the cubic meters cancel out. So therefore, you will just have 0.25 times 1,000. And this would be in kilograms. So when we multiply that, we get what? 250 kilograms. So always make sure you understand that you always want to have the thing that you're multiplying by, all right, the unit that you're trying to get rid of in the denominator so that the units will cancel out. So just take a few minutes. Make sure you look over your chart. Make sure you got everything correct. Make sure you put it in the calculator. Make sure you understand exactly how I got every step that I wrote. So let's look at English and metric equivalencies. I have 1 ounce is approximately 28 grams. I have 1 pound is approximately 0.45 kilograms. And I have 1 English ton is approximately 0.9 metric tons. Remember, this is approximates. That means they've been rounded off. So our first thing, we want to convert 160 pounds to kilograms. So we have 160 pounds over 1 times. Now, if you remember in the previous slide, we said that we have 1 pound per 0.45 kilograms. So that's the unit fraction that we're going to use. So we got 0.45 kilograms over 1 pound. So as you can see that our units cancel, so the pounds cancel out. So now you will have 160 times 0.45, and it's going to be in kilograms. So let's multiply 160 times your 0.45, and that gives us 72 kilograms. Just remember, when you multiply a fraction, you multiply straight across. All right. So let's look at this. Measuring temperature. Fahrenheit temperature scales. Water freezes at 32 degrees Fahrenheit. Water boils at 212 degrees Fahrenheit. Celsius. Water freezes at 0 degrees Celsius. Water boils at 100 degrees Celsius. So make sure you remember this, because you will have to use it. And we will convert from each scale, from Fahrenheit to Celsius and from Celsius to Fahrenheit. And we'll talk a little bit about Kelvin as well. So converting temperatures from Celsius to Fahrenheit, we have F, which is Fahrenheit, is equal to 9 over 5 times C, which is the Celsius degree, plus 32. Or we can say F is equal to 1.8 times C plus 32. These are equivalent. All right. So now, if we look at from Fahrenheit to Celsius, we have Celsius is equal to 5 over 9 times F minus 32. So all they did was they took the original, which was the F is equal to 9 over 5 times C plus 32, and they solved for C. And that's how they got from Fahrenheit to Celsius. So take a minute, write these down. Remember, at any time you can pause this if something's going too fast, and you can sit there and read over it again. All right, converting from Celsius to Fahrenheit. The bills from your European vacation have you feeling a bit feverish. So you decide to take your temperature. Your thermometer reads 37 degrees Celsius. The question is, should you panic? Let's see if you should panic or not. So we got F is equal to 9/5 times the 37 degrees Celsius. Then we have plus 32. So when we put that in the calculator, we got 9/5. Then it's times 37. Then you add 32 degrees to it. So it's Fahrenheit. It would be 98.6 degrees, which is normal temperature. Let me erase this. Yeah, 98.6 degrees. So no, you should not panic. All right, because it's normal temperature. You just feel feverish because that bill is high. Just keep that in mind. Now let's look at this one. It says the temperature on a warm spring day is 77 degrees Fahrenheit. Find the equivalent temperature in Celsius. So when we do this, we have C is equal to 5/9 times your 77 minus your 32. Therefore, we want to put this in the calculator. We have 5/9. And we multiply that times. You got 77 minus your 32. And you get what? Celsius equal to 25 degrees. So if you're putting in the calculator, go ahead and do what's inside parentheses first, then multiply by 5/9. Make sure if you have any questions, you contact me through Microsoft Teams, email me, or you make sure you hit me up on Moodle. Kelvin temperature scale. Absolute zero is the coldest possible temperature at which there is no heat and molecules stop moving. So 0 degrees Kelvin is negative 273.15 degrees Celsius, or it's called absolute zero. So water boils at 373.15 degrees Kelvin. Or if we look at the conversion from Celsius to Kelvin, we have K is equal to C plus 273.15. Or we're looking from Kelvin to Celsius, we have C is equal to K minus 273.15. So if we wanted to go from Fahrenheit to Kelvin, we would have to do what? Turn Fahrenheit into Celsius, then Celsius into Kelvin. Just keep that in mind. Now let's just look at the thermometers. And what this is doing is it's just a recap of everything that we been talking about. It just show you the different scales. So at 273.15 Kelvin, that's 0 degrees Celsius and 32 degrees Fahrenheit. At 373.15 Kelvin, we have 100 degrees Celsius and 212 degrees Fahrenheit. At 0 degrees Kelvin, or 0 Kelvin, we have negative 273 0.15 degrees Celsius, and then we have negative 459.67 degrees Fahrenheit, which is called absolute zero. Now, this is something you don't have to memorize, but it's always good to know. So if you see a thermometer, you won't read it wrong. So make sure if you have any questions about 9.3, you send me an email or you hit me up through Microsoft Teams. Now, when you hit me up through Microsoft Teams, if you have any questions about it, make sure you screenshot the problem or screenshot whatever your question is and send it so I can have it so I can work it out for you and I can show you what you're doing wrong.